Hi everyone, myself I am Jayamani, Assistant Professor in Department of Physics, Raman Arts and Science College, Satyamangalam. Today we have to say about Raman spectroscopy. First we discuss the following points: introduction, then principle, then instrumentation. Next one is types of spectroscopy, then advantage of spectroscopy. The last one is disadvantage of spectroscopy. First we discuss about introduction of the spectroscopy. Raman spectroscopy was discovered by C.V. Raman in 1928. It is a spectroscopic technique used to observe vibration, rotational and other low frequency modes in a system. Then Raman spectroscopy is commonly used in chemistry to provide a fingerprint by which molecules can be identified. When radiation passes through the transparent medium with space present, scatter fraction of the beam in all direction. Then the difference in wavelength in between the incident and scattered visible radiation correspond to wavelength in mid-IR region. IR means infrared region. Then principle. When monochromatic radiation is incident upon a sample, then this light will interact with the sample in same fashion. It may be reflected, observed or scattered in the same manner. It is scattering of the radiation that occurs which gives information about molecular structure. Then Raman is based on a scattering. The sample is irradiation with the coherent source, typically a laser. Most of the radiation is elastically scattered, that is Rayleigh scatter. Then a small portion is elastically scattered, that is Raman scatter, composed of Stokes and anti-Stokes portions. This later portion is what we are particularly interested in because it contains the information in which we are interested. Then the spectrum is measured with the laser line as a reference, hence the peaks are measured as they shift from the laser line. Then the emitter radiation of the three types. First one is Stokes scattering, second one is anti-Stokes scattering, then third one is Rayleigh scattering. This is in this diagram, this is Stokes line, this is anti-Stokes line. Then instrumentation. The modern Raman spectroscopy consists of the following three components. First one is laser source, second one is ample illumination system, suitable spectrometer. Here the parts are. Then source. The source used in modern spectrometer are nearly always laser because their high intensity is necessary to produce Raman scattering of sufficient intensity to be measured with a reasonable signal to noise ratio. The next one is sample illumination system. In sample illumination system, we have liquid samples. A major advantage of sample handling in Raman spectroscopy compared with infrared rays is because water is a weak Raman scatter but a strong absorber of infrared radiation. Then Raman spectrometer. Raman spectrometer was similar in design and used the same type of component as the classical ultraviolet or visible dispersing instruments. Most employed double scattering system to minimize the spurious radiation reaching the transducer. Then next type of Raman spectroscopy. These are the types. First one is resonance Raman spectroscopy, RRS. Second one is surface enhanced Raman spectroscopy, SERS. Then third one is micro Raman spectroscopy, MRS. Last one is non-linear Raman spectroscopic techniques. Then advantage of Raman spectroscopy. Sample can be analyzed through glass or a polymer packaging. Then no sample preparation needed. Then not infrared by water. Last one is non-destructive. Finally, we have disadvantage of Raman spectroscopy. Fluorescence of impurities or of the sample itself can Hide the Raman spectrum. Some compounds fluorescence when irradiated by the laser beam. Then sample heating through the intense laser radiation can destroy the sample or cover the Raman spectrum. Thank you.